Let p at x be the unique polynomial of minimal degree with the following properties. P at x has leading coefficient 1. 1 is a root of p at x minus 1. 2 is a root of p at x minus 2. 3 is a root of p at 3x. And 4 is a root of 4 times p at x. The roots of p at x are integers with one exception. The root that is not an integer can be written as m over n. What is m plus n? Let's break down all the information they gave us into some sort of usable format. So p at 1 minus 1 has, well, p at x, this one right here, has 1 as the root. So if you put 1 for x, that would equal 0. That's basically what that means. So therefore, p at 1 is equal to 1. The next one basically says that p at x minus 2 is equal to 0 when x is 2. So that means p at 0 is 0 when you substitute 2 for x. Okay, going that way, the next one would be, let's see here, p at 3x, so p at 9 would be 0. And then the last one, 4 times p at 4 would be 0. So let me just see if I did that right. I believe so. So our roots, well, this one I don't know. We'll just call it A. That correlates to that. This one, the root is 0. This one, the root is 9. And this one, the root is 4, correct? Okay, so our polynomial is obviously x times x minus 4 times x minus 9, and then times x minus 8. The a we don't know. And then we have this piece of information, so that means that p at 1, which would be 1 times 1 minus 4, which is negative 3, times 1 minus 9, which is negative 8, times 1 minus a, and that's equal to 0. So 0 would be 24 minus 24a, correct? If I did this right. 24. So p at 1 is 1. So this actually should be 1. Yeah, make sure I do that right. So that means that 24a is equal to 23. So a is equal to 23 over 24. So this 23 over 24 is that root that is not an integer. And it's of the form m over n. And therefore the m is 23. The n is 24. And therefore m plus n would be 23 plus 24. And that, of course, is 47, which is D. Circle C1, C2 each have radius 1, and the distance between their centers is a half. Circle C3 is the largest internally tangent to both C1 and C2. Circle C4 is internally tangent to C1 and C2, and externally tangent to C3. What is the radius C4? So here's a diagram, pretty much the same thing, and just labeled a little bit better. So let me explain. So we have C1 and C2. Those have a radius of 1. I'll just call it big R. And then you have C3. And then you have C4. And that I will give small r as the radius. So let's just backtrack here. So put both diagrams. C4 is our small one that you can see up there, the smallest circle. That's the radius we're trying to find. C1 and C2 are the ones that have a radius of 1, and those are the ones that you can see. There's C1 and there's C2. And then C3 is this guy. That's the one that is in the middle. So I just wanted to double check on that. So this has been labeled A, and this has been labeled B, and the distance between A and B is a half. And O is the center of C3, so the distance from A to O would be a quarter, which is a half of that distance. And then what you do is you take the center of C4, as you can see there, and from there you draw a line all the way to A, and you draw another line to O, and the line to O would be perpendicular to AB. And then you will notice that the labels 1 minus r and r plus 3 over 4 are there, and now we'll have to explain how that came to be. So here's the explanation. OT is basically from the center of C3. I'll just call that C3. This is C1. This is C2. And the small guy is C4. So OT is the radius of the C3. And we don't know what that is as far as I can tell. So, but that we can break that down into BO plus BT, correct? Now BO, I will just leave that for now, but BT is the equivalent of AT minus AB. Now AB we know, that was given up here, that's a half. So we'll put that in there. And AT is the radius of C1, right? Because A is the center. The distance between their centers. So A and B were the centers of C1 and C2 respectively. So since A is the center of C1, from A all the way to the end would be the radius, and that is 1. And then BO, well, BO is from there to there, which is exactly half of the distance from A to B, so that's a half of a half, because the distance from A to B is a half, so a half of that is a quarter. So that is the math. And therefore this would be 3 over 4. So OT is 3 over 4. And how does that help me? Okay, well, that means that the radius of C3, the radius of C3, therefore, is 3 over 4. That's how it helps me. Okay, I got it. So therefore, this side from here to there, from the center of C4 all the way to O, is indeed R plus 3 over 4, because R represents the radius of that small circle, and 3 over 4 is the radius of C3. And then this side from here to here, that side, that may not be as intuitive, but if you were to extend that line all the way to the end like that line from A like this, that is 1, because it's from the center of C1 to the edge of that circle, and that's 1. But then you have to subtract from it the radius of C4 in order to just get the distance from A to the center of C4. So hopefully that made sense. That's why it's 1 minus R. And therefore you have a Pythagorean relationship that 1 minus R squared is equal to 1/4 squared plus R plus 3 over 4 squared. And if you were to write that in letters, you could just write it, but I just wrote it in terms of the numbers and the letter R. So solving for this, I'm sure you could do it, and when you do, you'll get 3 over 28 for R, and therefore the answer will be D. If the positive integer C has positive integer divisors A and B with C equal to AB, then A and B are said to be complementary divisors of A. Suppose that n is a positive integer that has one complementary pair of divisors that differ by 20 and another pair of complementary divisors that differ by 23. What is the sum of the digits of n? So they're saying that n is equal to AB, I believe, and the divisors differ by 20. And then another pair differ by 23. Okay, so let's talk about it in terms of first the ones that differ by 20 and the ones that differ by 23. If they differ by 23, you can call them A and A plus 23. So these are the ones that, the divisors that differ by 23. Divisors. And then divisors that differ by 20, we're going to call A plus 1 and A plus 21. Not A and A plus 20 would be the logical way of writing it, but when you write it like this, it actually makes the calculation easier. Okay, so therefore, since AN is equal to AB, those are the A and B are the two divisors, N would be A plus 1 times A plus 21. Correct? And then on this side, it would be a times a plus 23. Okay, so that means that since n is equal to both of them, we can just equate them, right? So therefore, if we equate them, we'll get a plus 1 times a plus 21 is equal to a times a plus 23. All right, so let's see where this takes us. If we were to expand this, we'll get a squared plus 22a plus 21, and this is a squared plus 23a. Okay, the a squareds go, that's really nice, and then 21 is equal to a. Okay, that was nice. And therefore, these divisors, this one would be 22, and this one would be 42, correct? 22 and 42. And on this side, this is 21, and this is 44. 21, 44, 22, 42. Okay, and what are they asking for? The sum of the digits of n. Okay, so the n is, well, it's either 22 times 42, or it's 21 times 44. And fortunately, both of them equal 924. And therefore, the sum of the digits of that would be 9 plus 2 plus 4, which is 15, I believe. And that would be answer choice C. 6 hexagonal blocks, regular hexagonal blocks of side length 1 unit, are arranged inside a regular hexagonal frame. Each block lies along an inside edge of the frame and is aligned with 2 other blocks, as shown in the figure below. The distance from any corner of the frame to the nearest vertex of a block is 3/7 unit. What is the area of the region inside the frame not occupied by the blocks? Well, if my understanding is correct, we are basically taking the area of the big hexagon, so area of big H, and subtracting from it the shaded hexagons. How many are there? 1, 2, 3, 4, 5. So 6 of those small h. I hope you understand. And that is what they're asking for. Now, very helpful would be a formula for the area of a hexagon. And that formula is 3√3 over 2 a squared, where a is the side length. And really what we're talking about is regular hexagons, meaning all sides are the same. Okay, so that means since the side length is 1 for the big one, wait, is it the big one or the small one? The small ones, 6 regular, okay, the small ones have a side length of 1. So that means that this guy here is 3√3 over 2, and the side length I don't know, so we'll just call it s for now. S squared minus 6 times 3√3 over 2 a squared, but a is 1 because the question tells me that those smaller 6 regular hexagonal blocks have a side length of 1. Okay, so that doesn't look so bad. So that let's see if I can simplify this. I can't do much on this side, but this is going to be 6 divided by 2 is 3. 3 times 3 is 9. So 9√3. And then 1 squared, of course, is 1. Okay, but obviously I got to figure out the s since none of those have an s in them. Okay, that is the task of this question. So we have to figure out basically the side length of the big hexagon. So here we go. So what we're going to do is we're going to concentrate on trying to figure out the side length by concentrating on that region there. So this diagram is sort of a blow up of that part of the original diagram. So let's explain. In the original question, they told me that the distance from any corner of the frame to its nearest vertex of a block is 3/4. So that means this is the corner, and this is the nearest vertex. So that little guy is 3/7. So that's why this is labeled 3/7. And then if you draw these parallel lines, this will also be 3/7 right here. And then this is given that the side length is 1. So this is going to be 1. And then if you again draw parallel lines, see they're all parallel here. That's going to be 3/7. And then this guy is 4/7 because it's 1 minus 3/7. And then now this part is not immediately intuitive, but to get that, you have to look at angles. How do you do that? Well, first of all, you find out the internal angle of the big guy, the big shape, and that would be 4 times 180 divided by the 6 internal angles, right? Because a hexagon, see if I can even draw it properly, can be broken up into 4 triangles, and each triangle, the sum of the angles is 180. That's why it's 4 times 180. And then it has 6 internal angles, 1, 2, 3, 4, 5, 6, and that's why you divide by 6. And when you do that, you get 120. So that means that this is 120. And if that's 120, then that's 120, because of the fact that those lines were drawn parallel. And then since the sum of the angles of that quadrilateral would be 360, and we've already taken up 240, the other two have to add up to 120, and therefore the other two are 60 and 60. So that's 60. And therefore that's 60 for the same reasoning. And let's see if I keep going here. If I keep going here, it's the same kind of story. This angle chasing, we know that that internal angle is 120, and therefore we can figure out that angle being 120 in there. And then this would be 120, that would be 60, that would be 60, and therefore that's 60, and that's 60. So this is actually an equilateral triangle. So therefore that is why that's 4/7. It's the same as the other side. So we know that this is 1, this is 4/7, this is 1, and this is 3/7, correct? Because that's what the question told me. So therefore the side length, S, is 1 plus 4/7 plus 1 plus 3/7, and that is 1 plus 2 is 3. So this S is 3. So that's all we have to do now is just plug in 3 into that equation. When we do, we get 3 squared is 9. 9 times 3 is 27. Root 3 over 2 minus 9 root 3. So let's see if I did that correctly. I think so. So that's 13.5 root 3 minus 9 root 3. So that's going to be 4.5 root 3. And 4.5 is the same as 9 over 2. 9 over 2 root 3, I believe, is C. If A and B are vertices of a polyhedron, define the distance DAB to be the minimum number of edges of the polyhedron one must traverse in order to connect AB. For example, AB is an edge of the polyhedron, then DAB is 1. If AC and CB are edges and AB is not an edge, then DB is 2. If Q, R, and S are randomly chosen distinct vertices of a regular icosahedron, regular polyhedron made up of 20 equilateral triangles, what is the probability that DQR is greater than DSR? Well, I don't know what a whatever that is, it looks like. So let's talk about this using Euler's. You guys remember Euler's formula? That the vertices minus the edges plus the faces is equal to 2 of any of these kind of 3D shapes. Let's see what we can do here. So there's 20 equilateral triangles. So that means the faces, there's 20 of those guys. So I don't know what it looks like. So here's 1, here's 2, maybe there's a third one there. I'm just guessing what it might even look like. Something like this. I have no idea. I'm just making this up. And yeah, some strange 3D shape like that. I just wanted to kind of draw a little sketch, but that's certainly not what it looks like, but just to get an idea. Okay, so the number of edges, well, there's 20 faces. Each has 3 edges because each of them are a triangle. And then, of course, in the end, you have to divide by 2 because each edge is shared by 2 faces. So if we just did 20 times 3, we double count. So you divide by 2. So you get 30 edges. And then subbing it into here, we get V minus 30 plus plus 20 is 2. So that means V minus 10 is equal to 2. So V is equal to 12. So the number of vertices is 12. Okay. I think that's some decent progress, but let's just see. Now we have to actually tackle this guy. What is the probability of that? The probability that the distance from some random vertices, right? Yeah, these are random, randomly and distinct vertices. So the distance between Q and R, wherever Q is and wherever R is, I have no idea. There's Q, there's R, I don't know, S might be here, who knows. The distance from D to Q to R, we want it to be greater than the distance from R to S. And I'll just call that probability P. And therefore, since they're randomly selected, if we did RS to compare to Q and R, the other way around, that'd also be P. And therefore, they'd be equal when the probability is 1 minus 2p. Because all of these have to add up to 1, and I believe they do. Right? Because it can be either greater than, less than, or equal. Okay, so now let's try to see how we can draw this to make it have some sort of sense. So let's say the R is at the top, and then we're going to go, there's going to be, how many are there? 12. There's 12 vertices, right? 1, 2, 3, 4, 5, 6. So that this calculation was helpful. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and then 1 at the end. So that's going to be 12 in total. So like this. And then this one. These are all supposed to be straight lines, by the way. Okay. So the distance, this is 1. The distance here is 1, 1, 1, 1. Now the distance to here, the cumulative distance would be 2, 2, 2, 2, 2. Like, for example, if I was going from R to here, I'd have to go 1 and then 1. That's why I put a 2, the cumulative distance. And the cumulative distance to this point, which is the other end, I guess, would be 3, right? Because if I went from here, that's 1, that's 2, that's 3. Okay, so we want to actually work with this guy here, and then we can calculate P. For it to be equal, the distances would have to be both 1 or both 2, because we've got two different, we actually have 3 different vertices. We have Q, R, and S. So for example, this is R. So if Q is here and S is here, the distances would both have to be either 1, both distances, or both distances equal 2. Yeah, because if you can't put 2 vertices there. They can only go in these guys or these guys up here. Okay, so let's do the math. So therefore 1 minus 2p, if you have both distances 1, that means you're going to, from these 1, 2, 3, 4, 5, you're going to choose 2. And I actually illustrated that with my Q and R placings. So from 5, choose 2. And that would take care of both distances being 1. If you want both distances to be 2, you'd have to choose from these 5. And therefore from 5, choose 2. And then add them, because you want or this or that. And then divide by the total. The total would be from the, not counting this top vertice, from the other 11 vertices, you have to choose 2. And that is 1 minus 2p. And then when you do all this math, you'll get down to 20 over 55, which in lowest terms is 4 over 11. And when you solve for p, you'll get p equal to 7 over 22. And 7 over 22 is choice A.